Hello and welcome back to the ELECTRO-MASTER channel. In today's video, I'll walk you through the step-by-step repair process of the electronic boards from a Daikin air conditioner that was damaged due to a power surge. If you face similar issues or you're passionate about electronics repair, stick around. And don't forget, a like, a comment, and a subscribe really help me keep making these tutorials. Let's get started. This is the electronic board from the outdoor unit. I'm checking the fuse on the power supply circuit to see if it's blown, which would indicate a possible issue in the primary circuit. A blown fuse can signal a short circuit or overload, so it's important to determine whether the input voltage has affected key components such as the bridge rectifier, electrolytic capacitors, or the switching transformer. This check is essential to prevent further damage and to establish a starting point for troubleshooting. The fuses and primary circuit components are intact, indicating that the external unit's board hasn't been affected by the overvoltage. No visible damage or faults in the input stage suggest the board is still operational. The fuses and primary circuit components are intact, indicating that the external unit's board hasn't been affected by the overvoltage. No visible damage or faults in the input stage suggest the board is still operational. As observed, the fuse shows signs of smoke damage, and the protective varistor has exploded, indicating a surge event that affected the board's input protection components. I will carefully remove the circuit board and desolder the damaged components to prepare for inspection and replacement. A varistor is an electronic component used to protect circuits against voltage spikes. Essentially, it acts as a sort of shield that absorbs excess energy when the voltage in the circuit exceeds a dangerous level. Normally, the varistor has a high resistance, which means it doesn't allow current to pass through. However, when the voltage rises too much, its resistance drops sharply, allowing the current to safely flow to ground or the neutral line, thus protecting the rest of the components in the circuit. Usually, the varistor is used in parallel with sensitive components, such as circuit boards, and protects them from voltage fluctuations that may occur due to electrical discharges or other factors. However, if exposed to excessive voltage for too long, the varistor can suffer damage and, in extreme cases, even explode, as happened with the defective varistor in our case. It is very important to use equivalent components in terms of the values specified by the manufacturer, such as the varistor and fuse with the same amperage, to ensure proper circuit protection. Each component in an electronic system is carefully chosen to perform a specific function under precise operating conditions. If you replace a varistor or fuse with one of a different type or with different values, the risks are high, as the protection provided may be compromised. A varistor with a different working voltage than the original may not protect the circuit properly from overvoltages, and a fuse with a higher amperage than the recommended value may not blow in time during an overload, leaving the sensitive components of the circuit exposed to risks. On the other hand, a fuse with a lower amperage could blow too early, even under normal operating conditions, causing the system to stop unnecessarily. Therefore, adhering to the values and specifications of the original components is essential for maintaining the integrity and correct functionality of the circuit, protecting both the device and the user. After replacing the defective parts with new ones, I will carefully mount the board into the plastic support, ensuring all components and connectors are properly aligned to avoid any improper contact. It's important that the board is securely fixed to prevent any movement that could lead to short circuits or unstable connections. Once the board is correctly mounted in its support, I will connect the power supply, making sure all connections are secure and well established. I will power up the board to perform functional tests, monitoring the circuit's behavior, voltages, and currents to verify that all components are active and there are no operational errors. If all tests pass successfully, the repair can be considered complete and correct. I will connect the two boards using short wires to ensure proper communication between them. These wires will serve as temporary connections, allowing me to verify that the data and power signals are correctly transmitted between the components. It's important to ensure that the wiring is properly insulated to avoid any short circuits or interference, and that the connections are solid to guarantee reliable signal transfer during testing. This step will help confirm that the circuit functions as intended before proceeding with permanent reassembly. I will double-check by measuring the power plug with a multimeter to ensure there is no short circuit or incorrect voltage readings before proceeding. This step is crucial to make sure that the power supply to the circuit is stable and within the correct range, preventing any potential damage to the components or the rest of the system. It's important to verify that the circuit is clear and safe before applying power to avoid any issues during operation. In conclusion, I want to thank everyone for watching this video. After a detailed analysis, replacing the defective components, and conducting thorough tests, the repair has been successful. The boards are now ready for final testing, and the circuit is working correctly as expected. If you found this video helpful and liked what you saw, don't forget to give it a thumbs up, leave a comment, and of course, subscribe so you don't miss future tutorials and technical analyses. Your feedback is very important to me and helps me continue providing valuable content on the ELECTRO-MASTER channel. Thank you again for your support and for taking the time to watch. Until the next video, take care of your equipment and remember to check every detail before powering it up. Goodbye and see you soon.